Okay, in this set of notes, we're going to look at series, and we're first going to look at series in a general way, and then we're going to look at series with arithmetic and geometric. So a series is a sequence that's a sum, and as you can see, I've written out plus signs between them because it's a sum. It's not commas between the numbers, it's plus signs because you're going to add them all together. But who wants to write every number in the sequence? So we write the first three. As you can see, I've written the first three numbers, and then I put a plus, dot, 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 and then I've written the last number in my series. And that's a way that you can show a series. So here I have summation notation. This big E thing is called sigma. It's a letter in the Greek alphabet, and that word means sum in the Greek alphabet. Words, sometimes letters mean words instead of letters meaning letters in the Greek alphabet, like pi, it means a number. So we're going to do the first five numbers. So we're going to say 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5. So now I see they're going up by 1, so I can just go ahead and make the next two, and I put plus signs between them. Now, if I have more than 4 numbers here, then I want to take out the fourth one and put in dot, dot, dot. And so I don't have to show but the first three and the last one. So in this one, I'm going to put in 1. K is 1, so that's going to make 1/2. Plus, K is 2, 2 squared. Oh, my board's not writing. 2 squared is 4, divided by 2 is 2. And then we could be getting these off the calculator as well. We could type these formulas in y equals. I'm just doing the math by hand because I like to keep my brain working. 3 squared is 9, divided by 2 is still 9 divided by 2. I've got 3 numbers, so I put dot plus, dot, dot, dot plus, and then I put in 8 because the last one is 8. 8 squared is 64, and divided by 2 is 32. And that's all you do. Now, they don't have to start on 1, so in this one, K equals 0 would be what you get from the first number. If you put a 0 right there, that power comes out as a 1, so that's 1/3. And then you do K equals 1, so 1 plus 1 is 2. 3 squared is 9, and I'm putting plus signs between them. Then I do K equals 2 is 1 over, put in a 2, 2 plus 1 is 3, 3 cubed is 27, plus dot, 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 plus put in n minus 1. So if I do, and I'm going to do this over to the side here, n minus 1 plus 1, because I'm putting it in for k, this is k plus 1, then the 1's cancel out, and I get 1 over 3 to the n. And that makes sense, because this is 3 to the 1, 3 to the 2, 3 to the 3rd for those 3 numbers on the bottom. So sometimes you get a formula and not a number at the end. Now we're going to go backwards, because sometimes some people have written it out as a series, but you would like to write it as one of these big E's with a summation. So K equals 1 is what you'd like to always start with, although sometimes they can start with 0. And I go over here to look at what number didn't, like if I can't really tell from these, but if I look at this one, I see 13's been plugged in 2 places. So that must be where the K goes in the formula. So let's see if that works. If I put in 1, I get 1 over 2. If I put in 2, 2 over 2 plus 1 is 3. If I put in 3, 3 over 3 plus 1 is 4. So that is the formula, and this is where you put your n value for the last one was the 13th. Now in this one, I have over here, these 2 numbers are the same number, so that's probably your K. So if I do my summation, then for this one to work, if I put it over 1, there's no 3 on the bottom. So this is 3 to the 1, 3 to the 2, 3 to the 3. So this was 3 to the 0. So K equals 0 to 6. Now that's one way to write that formula. There is one other way to write that one. What if I told you you had to have 1? If K equals 1 here, then my formula is going to have to change slightly, because for this to be 1, and the power has to be 0 on the bottom to make it drop out and give me a 1 on the bottom, and I put in a 1 for k, that's going to be 3 to the 1. So I'm going to have k minus 1 to make my power work. And then when I put in 1 minus 1 is 0, 0 power makes it positive. Where up here, when I put in 0, it makes it automatically positive. So that means I have to go to 7, because k minus 1 would be 7 if I start with a 1 instead of a 0. So I stick to start with a 1 because most of them really should start with a 1, but 0 works so well for that. So now we're going to, I'll double check, make sure I didn't hit that. That's right. So find the sum of each series. So in this first one, you're supposed to plug the numbers from 1 to 4 in. That means you're going to get 4 numbers to add up. But there's nothing to plug the k in, so they're all 5. That's a constant function. So a constant function will actually add up to the same number each time. I'm trying to get my computer to pause, so there'll be a long pause in this video because I can't pause it. Go ahead. What's your name? Oh, thank you so much.
You're welcome.
I don't know what's happened to the computer, but it won't pause. It won't do anything. Uh-huh. Well, hopefully I can keep writing. Maybe I'll figure out how to do it. All right, so in the next one, we're going to put in the numbers from 1 to 5. So this is where your calculator could come in real handy, because you could type this 5k plus 3 in your calculator and just go get these 5 numbers off the list. But I'll just do them real quick, because plugging in a 1 makes 8. Plug in 2 times 5 is 10, plus that makes 13. Plug in 3 times 5 is 15, plus 3 is 18. It's going up by 5 each time, and I need 5 numbers, so I'll just make 2 more numbers. And then you add these 5 numbers up. And when you add those up, that's what you get for the formula. It gives you the sum. So let's say 21, 41, and 28. If I add a few of them together, it's going to come out with a 0, carry a 1. That's 90. So you can use your calculator to add it up. So in this one, we're going to have 3 numbers. So first we're going to put in a 1, 1 squared plus 4, which is going to be 5. Then we're going to put in a 2, 2 squared plus 4 is going to be 8. Then we're going to put in 3, 3 squared is 9, plus 4 is 13. And then we're going to add that up and get 26. So in the last example of this, they're wanting me to put this in and multiply some things together. So first we're going to have to really think about the fact that, you know, if I could put this in y equals, I don't know if I can get my calculator to come up or not. All right, so now we're going to try to type this formula, -1 to the k minus 1 times 2, k to the k power in our calculator. So we go over here to y equals. We type parentheses -1 parentheses to the parentheses x minus 1 power times parentheses 2 to the x power. Once we get our formula typed in, we go to second table and we copy down the answers for how many they ask us to do, which in this case was they asked us to add the numbers from 1 to 6, I believe. Yes, 1 to 6. So I'm going to go over and camera shot that so we can bring these numbers back over. So now I have what I need. I'm going to add up this column here and get my total. And what I do is I like to add all the negative ones first. So that's -20 and -64, which is -80. Then I go back and add the positive ones, because 8 and 32 is 40 and 2 is 42, so that I can say 42 minus 84, which is -42. So that's how you can sum up the numbers fairly quickly. Now, of course, if you use your calculator, you don't need to do all that. Hold on. Okay, yep. Now, this wasn't part of the notes. I think that's something I put in here when they asked me a question about homework. So let me delete that page. And this wasn't either. Alright, so the rest of the notes uses formulas off the formula sheet. So I would like you to stop the video and go and do the first 20 problems before you actually do this part. Alright, so as I was saying, arithmetic series uses a formula. You don't have to list all the numbers. I mean, would you want to list 1 through 20? I wouldn't mind listing 5 numbers to add them up, but I don't want to list 1 through 20. So some of the problems that we just did were neither patterns, some of them were geometric, some of them were arithmetic, but arithmetic and geometric have a better way to be done, and here it is. N over 2 stands for how many numbers do you want to do divided by 2? And then you take the first number and the last number and add them together. So in this problem, I'd have to know what the first number is, which is -1, and what the last number is in the 6th position, which is going to be 9. Then I will do S sub 6 because I've got 6 numbers I'm trying to do. 6 over 2, -1 plus 9. That's 8 times 3, which is 24. So I just added 6 numbers together with some little simple math. Alright, so on this one, first you're going to do, put in 1, that gives me 11, and put in 20. Well, I didn't type right at 20. That's -80 plus 15, which is -65. So now we're going to do S of 20, which is 20 divided by 2. You got 11 plus -65. So you get 10 times -54, which is -540. Now that's a whole lot faster than adding 20 numbers together. But what if you don't have it written in summation notation? Well, I know A sub 1 and I know A sub n. So this time I don't have to calculate those two. But what I don't know is what n is. So far in my formula, I've got the numbers going to be divided by 2, and the 2 and the 70 go in here. Let me find n. So first I got to make my A sub n formula. A sub n equals 2. They're going up by 2, so 2n minus 1. And I can go and plug that in the calculator. And y equals, without working it out, 2 plus 2 parentheses x minus 1 parentheses, and I take off the rest of that stuff, and I go to table, and I go down until I find 70. And 70 is 35. Now, it's not always half of it, so you need to make sure that you learn how to do that. It just happens to be in this problem, if I work that out, it would have a short formula. So then I'm going to do 35 divided by 2 times 72. Now, by hand, you could cancel that and make that 36, so that you could just come over here to the home screen and type 35 times 36. But you also could just type the whole thing in and get the 1260. So if I added all those 35 numbers together, it would add up 1260. So here's A sub 1, and here's A sub n. So again, I don't know n. I've got the first number, I've got the last number. So I need to make my arithmetic formula so I can go put it in the calculator. So A sub n equals -15 plus 6n minus 1 because it's going up by 6's. So I go to the calculator, type that in, y equals -15 plus 6 parentheses x minus 1 parentheses. I go to table, start, and tell it to start on 1 again. I forgot what number I'm looking for. I'm looking for 51. So I go to tables and look for 51. And 51 is 12. So I come back and put a 12 in. So S of 12 is going to be equal to 6 times 36. So that's going to come out to be 216. And again, you can multiply and add all that up in your calculator. You don't have to be doing it the way I'm doing it. So in these last two examples of arithmetic, we're looking at the variable term is on the end instead of a number. So this is a sub 1 and this is a sub n. And all this means is I won't be able to get a numerical answer, but I still can do it. I can still figure out what S sub n is because I can put in n over 2, 1 plus 2n minus 1. I don't know what position 2n minus 1 is in because it's the nth position. Then the 1's will cancel out, give me 2n, 2 over n times 2n. The 2's cancel, and my formula is n squared. Now let's see if that makes sense. If I only have one number, 1 squared is 1. If I add these two together, that's 4. Two numbers, 2 squared is 4. If I add 1 plus 3 plus 5, that's 9. Three numbers, 3 squared is 9. So it's giving me the formula to be able to calculate any amount up. Let's try that again. A sub 1 is the first number, and A sub n is the last number. So S sub n equals n over 2, because I still don't know what position that's in, because it's got an n in it. Negative 9 plus negative 12 plus 3n. So I've got n over 2. I've got 3n minus 21. Now, a lot of students think you need to factor at this point, but actually you're supposed to be multiplying. So I'm going to do two things. I'm going to do n over 2 times 3n, and I'm going to do n over 2 times negative 21. So that makes it 3 halves n squared, because n times n makes n squared, and the 2 comes up under the number. And it's going to be negative 21 over 2 n, because n times that would put the n next to it. And that's your final answer. So when you don't have numbers to plug in, it's a little bit more work algebraically. Now let's look at geometric. There are two kinds of geometric. There's geometric where you know what number you want to stop on, and then there's geometric that goes to infinity. And the infinity one doesn't have a symbol at the bottom of the S. S stands for series or sum, so you know you're adding them up. But this one I don't have to know the last number, I just have to know the first number. So 20, 1 half to the 1 minus 1. 1 minus 1 is 0, that part drops off, it's just 20. So I'm going to sum up 5 numbers by putting the first number 20, 1 minus the half is the R, but this number is not always A. And we'll talk about that again in a minute. To the 5th power, all over 1 minus 1 half. First of all, you need parentheses around the half so the power gets done correctly. Then you need parentheses around the bottom because you got a subtraction problem. Now let's set up the second one so you can see the difference. So 10 times 3 to the 1 power comes out to be 10 times 3 is 30. As you can see, when the k minus 1 is not up here, the number in front is not the first number. But when the k minus 1 is up there, the first number is the number in front. So then I'm adding up 6 numbers. So I'm doing the first number is 30. 1 minus 3 to the 6th power over 1 minus 3. And you just type those in a calculator. So let's look at that. And let me kind of get rid of part of my view here. Well, I didn't get rid of part of my view. There we go. So on the home screen, we could type 20 parentheses 1 minus, and I'd put 0.5 in because then you don't have to type the parentheses, to the power of 5 parentheses divided by parentheses 1 minus 0.5 parentheses. And that comes out to be 38.75 for the first one, and that's the total answer to that. So then we did the other one, 30 parentheses 1 minus 3 to the 6 parentheses, divided by 1 minus 3. Now, you could do the 1 minus 3 in your head and put it in negative 2 is what you're dividing by if you want to. Or you don't have to. You can let the calculator do it all as long as you put parentheses the way I've showed. And it come out 10,920. So if your R value is more than 1, you're going to get a huge sum. And if your R value is less than 1, you're going to get a much smaller sum like the 3875. Now, what do you do if it has letters in it? And those letters could be written on the sequence like I did with arithmetic, or they can be written on the summation like I did here. So first, you're going to do S sub n equals A, which in this case is the 4 because this has the k minus 1 up here, parentheses 1 minus, this is your R, so that's 2.5, to the n power, because that's what you are doing it to, all over 1 minus 2.5. Now you're saying, well, what am I going to do? I don't have a number for n. Well, you're just going to work the outside. You're going to do, first subtract the bottom, and that's going to come out negative 1.5. Then you're going to say 4 divided by negative 1.5 on the calculator. Whoop. 4 divided by negative 1.5 on my calculator comes out to be, math frac, negative 8/3. And so you're going to put that in front of your parentheses, but you're not going to distribute it because there's still an n up here on this power, and so therefore you can't multiply into a power problem. Let's try that again. S sub n equals, actually it's S sub n minus 1 equals, because you're putting in n minus 1. Your first number is 5 because you still have that. Here's your R. 1 minus 0.4 to the n minus 1 power, all over 1 minus 0.4. So you're going to subtract the bottom and divide it into 5. So you could do that all at one time. 5 divided by parentheses 1 minus 0.4 parentheses, math frac, and get 25 over 3. And then you can just put the parentheses beside it or on top, either way. And that'll be your sum. Now the last part we have is to infinity. And first of all, this only works for decay problems. That's when R is less than 1. With the absolute values on there, you're just looking at the positive or negative, doesn't make any difference. It's just got to be less than 1. So if it's not, then you wouldn't be able to do it. So if I give you an R like 40 times 3 to the k minus 1 power, you can't do infinite on that because 3 is bigger than 1. But if I do it to the half power, I can. The formula for that does not have a subscript, although you could write an infinity symbol down there, but there's not on the formula sheet that way. It's the other formula without the parentheses on it. It's A over 1 minus R. So here's A and here's R because this is k minus 1. I don't need to plug in 1. That's going to come out 0 and give me the 0 powers always drop off. So I do 40 minus over 1 minus half. 1 minus a half is a half. So if you flip and multiply, you get 40 times 2, which is 80. So it's real simple to do that. Now, sometimes it might be more difficult than that. So if you can't do the math by hand, you can put parentheses around it, type it in the calculator. Let's look at our second example. This is A and this is R. So S to infinity is going to give me 6 over 1 minus negative 2/3. So that means plus positive. So if I add 1 to 2/3, I get 5/3. If I flip it and multiply it, I get 18/5. All right, let's look at 2 more examples. Another way they can write it is they can give you the sequence with the dot, dot, dot on the end, and that tells you you're going to infinity because there's no number on the end of the sequence to stop at. So S to infinity is equal to 100 over 1 minus, I'm dividing by 2, so that means I'm multiplying by a half, because you can't say dividing in these formulas. It's all about multiplying with geometric. So 100 divided by a half is 100 times 2, or 200. And then in this last one, if you put this over 1, you can see the top's being multiplied by 2, and the bottom's being multiplied by 3. So there's your ratio. You have s to infinity is equal to 2 over 1 minus 2/3. 2 over 1/3 means 2 times 3 over 1. The total of this problem is 6. So that's the end of our notes. You may need to go back and watch these a little at a time to make sure you're doing the right steps, or look at your notes that you've written down and do the rest of the worksheet on arithmetic and sequences. These were the notes for Wednesday and Thursday. The assignment is due on Monday.